For most of human history, the universe seemed eternal. The stars appeared fixed. The night sky changed slowly. Nothing suggested a beginning. Then, in the 20th century, everything changed. Astronomers discovered that galaxies were moving away from each other. The universe was expanding. And if the universe is expanding today, then in the past it must have been smaller, hotter, denser. Eventually, this reasoning led to a remarkable conclusion. The universe had a beginning. This event became known as the Big Bang. But the Big Bang raises a deeper question. If the universe began, what existed before it? And perhaps an even more unsettling question. Does the word before even make sense? The Big Bang was not an explosion in space. It was an expansion of space itself. There was no center, no outer boundary, no empty void surrounding it. Every point in the universe was once compressed into an extremely dense state. As space expanded, it cooled. Within fractions of a second, fundamental forces separated. Particles formed. Energy condensed into matter. After about 380,000 years, atoms formed. Light began to travel freely. That light still exists today. It is known as the cosmic microwave background. It is the oldest light we can observe. But it does not tell us what came before. Physics allows us to describe the universe back to a tiny fraction of a second after the Big Bang. But beyond a certain point, the equations break down. At extremely high densities, gravity and quantum mechanics collide. General relativity no longer provides reliable answers. Quantum theory becomes unstable. This boundary is known as the Planck time. Before that moment, our current physics cannot describe reality. It is not that we know what happened and refuse to say. It is that we genuinely do not know. One possibility is that nothing existed before the Big Bang. Not empty space, not darkness, not even time. In Einstein's framework, space and time are connected. They form space-time. If space-time began at the Big Bang, then asking what happened before it may be meaningless. It may be like asking what lies north of the North Pole. There is no north beyond it. Similarly, there may be no before beyond the beginning of time. However, modern physics rarely accepts simple answers. Some cosmologists propose that the universe emerged from a quantum fluctuation. In quantum theory, even empty space is not truly empty. It contains fields, energy, instability. Particles can briefly appear and disappear. If quantum fluctuations can create particles, could they create entire universes? Some models suggest they can. In this view, the universe emerged from a quantum vacuum, not from absolute nothingness, but from a deeper physical reality. When scientists studied the early universe more closely, they discovered something strange. The Big Bang model worked well, but it had problems. Why is the universe so uniform? Why is it so flat? Why do distant regions share the same temperature even though they should never have been in contact? To solve these problems, physicists proposed a new idea: cosmic inflation. According to this theory, the universe did not simply expand after the Big Bang. It expanded at an unimaginable speed within a fraction of a second, faster than the speed of light. This does not violate physics because it was space itself that expanded, not matter moving through space. Inflation stretched tiny quantum fluctuations to cosmic scales. Those tiny irregularities later became galaxies, clusters, and the large-scale structure of the universe. But inflation introduces a deeper mystery. What triggered it, and what existed before inflation began? Some models suggest that inflation may not have been a single event. It may be eternal. If inflation can happen once, it may happen many times. In some versions of inflation theory, space continues expanding forever in certain regions. New bubble universes constantly form. Each bubble becomes its own universe, with its own physical constants, its own particles, possibly even its own laws of physics. Our universe would be just one bubble in a much larger cosmic ocean. This idea is known as eternal inflation. It naturally leads to the concept of a multiverse. But this raises a difficult question. If there are infinitely many universes, what does that mean for explanation? Are we simply in this universe because it allows life to exist? Is our reality just one possibility among endless variations? The multiverse is not science fiction. It emerges from equations developed to solve real cosmological problems, yet it remains unproven and possibly untestable. Not all physicists accept inflation. Some propose a very different idea. Perhaps the universe did not begin once. Perhaps it cycles, expands, contracts, and then expands again. In cyclic models, the Big Bang was not the ultimate beginning. It was the end of a previous universe. In some versions, two higher dimensional membranes collide. Their collision releases enormous energy. That energy appears to us as a Big Bang. In this view, the universe may have no true beginning. It may have always existed in one form or another. But these models face challenges. They must explain the observed expansion, the cosmic microwave background, and the apparent acceleration of space. So far, no single model has replaced inflation. Another idea is known as the Big Bounce. Instead of beginning from a singularity, the universe may have contracted from a previous state. At extremely high density, quantum gravity effects could prevent total collapse. Instead of a singularity, there would be a bounce, a reversal from contraction to expansion. This idea attempts to merge quantum mechanics with gravity, but quantum gravity remains incomplete. We do not yet have a full theory that describes what happens at those extreme conditions. Perhaps the most difficult question of all is this: why is there something rather than nothing? Even if inflation explains the early expansion and quantum fields explain fluctuations, we still must ask, why do quantum fields exist at all? Why are there laws of physics? Why is there a framework within which a universe can emerge? Some physicists argue that nothing may be unstable, that the absence of everything is impossible. In that sense, existence may be unavoidable, but this is speculation, and at this boundary, science meets philosophy. Our understanding of the early universe depends on observation, but observation has limits. The cosmic microwave background is the oldest light we can detect. It comes from a time when the universe became transparent. Before that moment, light could not travel freely. The universe was opaque, dense, hot. Beyond that barrier, we cannot see with light. It is like trying to look through a wall of fire. To probe earlier times, scientists rely on mathematics, on particle physics, on indirect evidence. But mathematics can only guide us as far as our theories allow, and our theories remain incomplete. A point of infinite density, infinite temperature, infinite curvature of spacetime. But infinities in physics are usually signs of failure. They indicate that a theory has reached its limit. Many physicists believe that the singularity is not real. It is a placeholder for a deeper explanation. A future theory of quantum gravity may remove the singularity entirely, replacing it with something finite. But until that theory is complete, we do not know. Another question emerges. Is the universe finite or infinite? Observations suggest that space is nearly flat. If it is perfectly flat, it could extend infinitely. If it is slightly curved, it may be enormous but finite. If the universe is infinite, then somewhere, every possible arrangement of matter may exist, even identical copies of our observable region. This idea is unsettling, but it follows from simple geometry and from expansion. Some cosmologists suggest that our universe may exist within a larger framework, not simply as one bubble among many, but as a structure embedded in a deeper reality. This meta-reality may have dimensions we cannot perceive. Physical constants may vary across it. Time may function differently. In this context, the Big Bang was not a beginning, it was a transition from one state of reality to another. But such ideas remain speculative. We lack the tools to test them directly. Perhaps the question itself is limited by human thinking. We assume that everything must have a cause, a starting point, a temporal sequence. But causality may not apply at the deepest levels of existence. The universe may not require a beginning in the way we imagine. Our language evolved to describe everyday events, not the origin of space-time. When we ask what existed before the Big Bang, we may be applying a concept of time that does not belong there. Modern science does not give us certainty, it gives us boundaries. We know the universe expanded. We know it was once hotter and denser. We know that space and time are intertwined. But beyond the Planck scale, our knowledge dissolves. Before the beginning may not be a place, it may not be a moment. It may be a region where our current understanding simply does not apply. And perhaps that is the most honest answer science can give. Not that there was nothing, not that there was something, but that the question itself points beyond the limits of our present knowledge. The universe does not offer simple answers, it invites deeper questions, and the search continues.